Well, good evening, everyone, and welcome to Environmental Coffeehouse. I am terribly sorry, but Antonio cannot be with us tonight, and I am. But Jennifer is actually hosting. So, Jennifer, take it away, and I will just do what you guys would like me to do. And I'm sorry about Antonio. He had a last minute snafu, so you got us.
C'est la vie. Life happens, you
Life
know?
happens.
So, welcome Nick Humphrey, Jim Massa, me, Jennifer Hynes, and of course, Sandy Schoelles, who makes this all possible. None of us would be here or communicating or having this community at all without Miss Sandy Schoelles. So, big hand to
Okay.
Sandy.
Yay, big hand to Sandy. All right. I wasn't prepared to be with you, but I'm happy to be here. Okay. I'm happy to be here, guys. So go
Yeah.
ahead. Start her out.
Well, we haven't really talked about what we're doing tonight. One thing I wanted to talk about, since we have Jim Massa here and also Nick Humphrey, is there was a thread recently on Twitter by Chris Van Steenbergen, and he says the Atlantic meridional overturning circulation is getting unstable. A full collapse is projected between mid June and mid August based on predicted Atlantic SSTs and predicted temperature anomalies at the entire column south of Greenland. So he's saying it's minus 9C to minus
Ooh.
13C below. That's an anomaly. So all of that cold
Wow.
water that's dumping off of the ice sheet from Greenland into the Atlantic Ocean is making the entire water column 9 to 13 degrees C colder than usual. And this is a big enough thing that it can stop the entire Atlantic meridional circulation. And I wanted to turn it over to Jim and see if he's heard about this and if we could talk about some of the supporting evidence on this, right? Do you know about this one?
I have. There's a couple things to keep in mind. One is that the source water is not just only from Greenland, but from what's coming out of the Arctic Ocean, which then ties into what the Arctic Dipole is doing. The Arctic Dipole right now is currently in a situation that is promoting pushing ice out through the Fram Strait. So that is contributing to the ice that will then eventually melt and create this freshwater lens in the surface of the northern Atlantic.
Mhm.
Now, yes, 9 to 13 C colder is significant. What does it do to the density? You have to remember that the density of seawater is not only a function of temperature, but also of the salinity, the salt content. So, and this is one of the major things in oceanography, which is more dense, cold, not as salty water, or warm, very salty water? And the answer is depends. Depends where you're at, depends on
Mm.
the precise salinities, depends on the mixing, you know, regimes or the mixing mechanisms in place. So you can have this very cold water, but it's also not very salty. So what does that do to the density? Well, that's why it's unstable, because in some cases it could make it more dense because it's so cold, like towards the 13C side of thing. But in other cases, if it's towards the 9, 7C side, well, it may be cold, but it may not be salty enough to sink. So
Mhm.
that that's the conundrum. That's the where it becomes difficult to tease out the precise, minutia in it, and hence his statement of it is unstable is, I think, an apt and a correctly applied term for what's going on here. So you could get some sinking, you could get no sinking. You could get sinking as usual, although I think at this point now, the the last situation, the last option is least likely. So
Mhm.
it's going to be topsy turvy, and that's an extremely scientific term.
Yeah. Well, this guy does
Oh,
say that the conditions needed to stop the AMOC will likely be generated this summer. He says it's going to be a little colder than really is needed. He says he's not predicting anything, but these facts are based on pure physics. So, we may see if the AMOC, we've noted and scientists have noted that the AMOC is slowing down, but if Greenland just dumps a whole shitload of cold water right there, I mean, it could significantly stop it.
oh,
Well,
Yeah.
we've been measuring the slowdown of AMOC for at least 15, if not 20 years. So this is not exactly a news flash. It's just becoming more prominent because, well, we have technology and social media, and people are actually now starting to pay attention. But
Mhm.
it goes back to a team of Norwegian researchers that have been noting and measuring the slowdown. A team out of Dalhousie University in Halifax, well, technically Dartmouth, Nova Scotia, Twin City, Halifax, and Dartmouth. They've been measuring the slowdown since like 2003 or something like that. And yes,
Mhm.
there is definitely a slowdown in what we call chimney formation when the deep water is forming. So yes, it is slowing down. Um, is the slowdown another one of these going to become exponential like everything else? Well, that remains to be seen. But you have to bear in mind the work of Wally Broker, who he was the kind of the really the grandfather of climate science. A lot of what the techniques used today is what he developed, and he did a lot of work on the conveyor belt, and he actually demonstrated that the significant slowdown, if not a complete stoppage of AMOC, could take place within decades, not centuries as
Mhm.
previously thought. And it
Everything
was as
everything is faster.
yeah, to quote Wally, he basically says like flipping a switch. So will it completely shut down this summer? It's sort of like, is there going to be a BOE? I mean, instead of like focusing on an event, although I would call the shutdown stoppage of AMOC to be perhaps more telling than perhaps a BOE, because we already know what's going on in the Arctic. BOE or not set aside, we know the Arctic is just warming. Now the indications are 4 times as fast as the rest of the planet. So,
Mhm. Indeed.
AMOC slowing down is going to be noteworthy. But
Oh,
you
completely.
know,
Yeah.
if you ask me what this means for the climate, if you had asked me this question 3, 4, 5 years ago, I would have said, well, based on again the work of Wally Broker, the indications are we have a planetary wide cool down, definitely a hemispheric cool down, and that could
Mhm.
tilt the planet to cooler conditions, i.e., possibly promote glacial sheets forming, and you have another ice age of some sort. I am now of the opinion that because of all the ocean heat, 240 or so, 240 zettajoules of heat energy in the ocean, that AMOC slowing down will probably have more, or stopping, will probably have more of a regional impact as opposed to a hemispheric impact, because all that ocean heat content will diffuse to the atmosphere and will, you might have that North Atlantic section cooling down, but the rest of the planet is going to probably still keep warming.
Yeah, indeed. And the AMOC probably won't recover until almost all the ice is on Greenland has melted. So I'm not sure exactly how long that would be, but certainly more than 50 years, probably a couple hundred years for all the island ice on Greenland to melt. So, this could just shut down while Greenland is melting, and then who knows what's going to happen after that. What do you
I'll tell you
think?
where the real concern for me with AMOC shutting down is what it will do to ocean productivity. That to me is the real
Mhm.
concern because you're adding another stratification aspect
Yes.
to the ocean. But also keep in mind that when AMOC sinks, to form the North Atlantic deep
Mhm.
water, which then cruises back south at about 2,000 meters or so, eventually a branch of that it splits off. Some goes to the Indian Ocean, the Pacific Ocean, etc., etc. But one important branch of that does upwell in what we call the Antarctic divergence zone. And the Antarctic
Mm.
divergence zone is a major region of productivity. In fact, it is uh, the most productive open ocean
Mm.
productivity
Isn't
region in the planet. So,
isn't
if
that
I
where
may,
we get most of our krill is from this area?
yes.
The krill?
So the problem
Well,
is
not
if you
our
shut
krill,
down
but
AMOC,
krill is that down there. Yeah.
if you shut down AMOC, you're going to eventually have that upwelling no longer take place because that upwelling brings in much needed nutrients for the phytoplankton so they can do their thing. And then you have the little zooplankton eat the phytoplankton all the way up to krills and baleen whales. So you shut down AMOC, you could collapse eventually the ecosystem of the Southern Ocean, and that would be calamitous for the just plain simple.
Yeah. No kidding. And just like we have Arctic amplification here in the Northern Hemisphere, there's also Antarctic amplification. And I've seen evidence of that cold air from Antarctica becoming more unstable and spilling out over, various land masses, South
Mm.
America or whatever. Have you noticed that there's an increase in Antarctic amplification as well?
I think Nick being the atmosphere guy here, we can probably talk more to that. But I've been keeping more
Okay.
tabs on the oceanic aspect of it, which is showing some interesting trends in that there is actually a lot of heat in the Southern Ocean, and that is heating up.
Mhm.
But what is interesting is that seems to be increased Antarctic bottom water forming because most people are
Increased
not aware.
Antarctic. What is
Bottom
increased
water?
Antarctic bottom water? What is that?
There's two major sources for oceanic bottom water. Everyone is familiar with the North Atlantic. There's also one that comes off the continent of Antarctica.
Is that right?
It's called Antarctic bottom water. And when you look at a
Huh.
vertical profile of the ocean, okay, you have the NADW, North Atlantic deep water, comes down, cruises down about 2,000 meters or so. Well, underneath that is Antarctic bottom water that we start seeing in the southern Atlantic.
Mm.
Oh.
So it's actually we are starting to see some profound changes through the vertical structure of the ocean, especially in the North and South Atlantic,
Right,
because
because the water
you have the
columns are
continuity.
getting colder for all this cold water dumping off of the ice sheets in the north and the south.
Well, it all depends how far that cold water sinks because of again density consideration. But the Antarctic bottom water has reaches far up into the Atlantic, and again, it's so dense because it's like very cold and very salty, and it just slides right
Mm.
under the North Atlantic bottom water. So it has interesting implications for the oceanic structure, and that of course means heat transfer as well. And
Hmm.
what's going to happen from that? We just have to do the research, collect the data, and see what the indications are.
Mm.
Mhm. Mhm. Nick, I was wondering what you've been thinking about lately from a meteorological perspective. You've
Well,
wondering if you wanted to jump on
thinking about
in.
thinking about the AMOC. I haven't seen any recent research in the past couple of years, but I know uh, Dr. Hansen had some concerns back in the mid 2010s. He wrote a paper on the weakening of the of the AMOC and other issues related to sea level rise, including exponential sea level rise, was a concern of his. And one of the things discussed in that big paper that he wrote I think it was in 2015, was this idea of the um, cold water buildup in the North Atlantic. All this cold water spilling into the North Atlantic, causing more intense storms in the North Atlantic. And there have been some historical paleo climate records showing huge storms that had occurred in the Atlantic in past time periods and during the time humans or some form of humans were on the planet. Um, and you think about the effect that the ocean has on the atmosphere. The ocean sea surface temperatures change very little day to day. They change very slowly over a course of months just because of the high heat capacity of water, and particularly the huge deep oceans. And so you get hot, large temperature gradients that form in the ocean. They can drive strong atmospheric circulations because the atmosphere responds with very strong temperature gradients in the atmosphere in response to that, to what's going on in the ocean, the sea surface temperatures. So you can get very strong, what we call baroclinic storms that are driven by temperature contrast. And so,
What is that? Borrow? Can you say that again?
baroclinic,
Baroclinic.
yeah, it's
Okay, thank you.
basically, yeah,
Is baroclinic and barotropic,
yeah,
right?
baroclinic is
Yeah.
basically driven by uh, strong atmospheric differences and temperature and density over relatively short distances. So you can get that's what drives the jet stream. Actually, is strong baroclinicity, as they call it. So, um, but you could see if the AMOC continues to weaken, you could see those regional changes in the North Atlantic where it maybe becomes cooler or at least warming slows down in Western Europe and the British Isles, and you get the generation of really intense storms that form along these intense baroclinic zones, these zones of strong temperature contrast that form as a result of all this cold water that's uh, butted up against much warmer water in the farther south, and the atmosphere responds, but having the same intense temperature contrast in the atmosphere. Um, so there's a lot of unknowns that still need to be figured out with regards to the effect that this weakening circulation in the ocean would have on the ocean, on as Jim mentioned, ecosystems, and then also on the atmosphere that could have impacts on land with significant um, um, abrupt changes in climate and extreme weather events. It's as a scientist, it's a curiosity, but as a just an average person living alive, it's kind of scary because you don't want to necessarily see very abrupt changes in the environment in a very short period of time that could have very damaging effects on society and on ecosystems, both in the ocean and on land.
Hmm. Well, I think
I'd like
we're.
to build on.
No,
I'd
go
like to
ahead,
build on
please.
something Nick just mentioned. Is another consequence of AMOC slowing or stopping is what happens to the Gulf Stream, and of course the Gulf Stream brings a warm warm temperatures from lower latitudes to higher latitudes. Well, the Gulf Stream will slow down considerably. Therefore, this will further increase the intensity of a temperature gradient between low and high latitudes that can lead to, as Nick said, more intense storms. So that's something else to keep in mind, is to look at what happens with the Gulf Stream, in that we'll no longer be able to bring the warmer temperatures to northern latitude to moderate higher latitudes. So then what happens is the higher latitudes, at least regionally, will get cooler and the lower latitudes will get warmer. As I said before, to me, the big question is what happens to all that ocean heat energy? How much of that starts diffusing because the ocean is stratifying? We have that heat trapped most of it, some, what is it, 68, 70%, something like that, of the all that 240 or so zettajoules in the upper 700 meters that's being trapped, that ocean stratified, that's going to start diffusing back into the atmosphere.
Mm-hmm.
So now we have this heat input, and what does that do to the atmospheric circulation patterns? Well, you know,
Yeah, exactly,
as a
exactly,
as a
Jim.
scientist, it'd be interesting, but
Yeah.
I mean, the oceans have been absorbing pretty much over 90% of the excessive heat that we've been pumping into the atmosphere with all our carbon dioxide abuses with fossil fuels, etc. I mean, at some point, the ocean is going to kick back. And it seems like we're getting to that point at this
you
point.
can think of the oceans as a big capacitor just waiting to discharge.
Hmm. Oh,
I think that's
it's
yeah. I
true.
think that's kind of wild. It is. I just want to tell you guys that I told everybody to put a queue when they have questions, and we'll save some time at towards the end. All right, Jen.
Sounds good.
Okay.
Another thing that I've been noticing and wanted to ask you guys if you had seen this intense heat wave in Europe that went through the entire Iberian Peninsula, all through Spain, all the way up through Poland, in kind of like this diagonal fashion, and just roasting pretty much all of Western Europe. Did you guys tune into that at all? Did you
Yeah,
notice that?
I've been sort of keeping an eye on it here and there, and yeah, it's been very hot, like over 100 degrees in interior parts of Spain. I think in parts of Portugal as well. Over the um, and I mean it's been extremely warm um, there lately, and yeah, it it's I mean, in terms of like the meteorology, it's just very strong high pressure systems. You're getting heat being driven in from parts of the Sahara, North Africa. It's and yes, also been a lot of heat in the past couple of months in India and Pakistan. Somebody mentioned that. So there's been a lot of heat going
Very
on in the
much.
northern hemisphere. I remember it being this bad, being in 2017 and 2018. There was a lot of heat going on in the northern hemisphere, and we seem to be repeating that again this year. Lots of intense heat. I think the hottest, I think Morocco. I'd have to check again because there's a
Mhm.
meteorologist that tracked
Morocco
that.
hit
Yeah,
the
Morocco
hottest
had its
temperature
yeah
ever.
its
Yeah.
hottest reliable May temperature on record, reliably measured
Right.
May temperature on record. Yeah, I mean it's um, yeah
Yeah.
it it, it because it's kind of funny because you're in a sad way because you even though not necessarily every single event that we can track we can we can confirm this was enhanced by or more made more likely by climate change. But we know in general, more heat events are occurring on the planet because of climate change. In general, we know that because we know the planet is warming quite dramatically across the entire world in terms of the bell curve, being shifted and getting hotter and hotter days versus colder days. So
Yeah.
it just but to actually
No,
see
it's
it is in real time is quite dramatic. You see what's going on in India and Pakistan, and now in Spain and parts of
Oh,
Central Europe, and I
Pakistan.
mean they had just yesterday actually. This isn't heat related. Um, they had some spectacular storms in parts of Quebec. Some
oh,
very high
really?
wind thunderstorms. Yeah, they
Oh,
moved
the
through. It's called a
chat's talking
derecho.
about that. Yeah.
Yeah, it's called a derecho, where you have a long-lived thunderstorm complex that moves through, and it can last for many hours and cause um, major wind damage um, and across an area over a period of 6, 8, 10 hours. I mean, those storms can last a very long time. Um, we know that. and I actually knew somebody back at University of Nebraska when I was a meteorology major there that did did like dissertation research on on these convective systems, and that they seem to be becoming more frequent over the past several decades, and because they're trying to figure out research more into whether thunderstorms, severe thunderstorms, tornadoes are becoming more frequent or intense because of climate change. It's hard to do because of the scale of them, and climate models don't go down to that kind of scale yet. Um, but they're trying to figure out if there's more frequent storms, convective storms, thunderstorms, because of climate change, because they have such devastating impacts. I mean, today is actually the 11-year anniversary of the Joplin tornado, the EF5 tornado that struck Joplin, Missouri, and killed 160 people. So,
And there were
our
just
world,
tornadoes in what is it, Michigan, that were pretty scary, and
yeah,
it was an E3, I believe it was an E3, and so anytime I see the storms, Jen, you saw I was posting yesterday, like, oh my God, and I thinking, is it going to hit me again? It's just it is terrifying to be living in this time of climate change. It's not terrifying. All right,
Yeah.
it's disturbing because
yeah, it's
nothing is like it was. You can't count on anything.
Everything
yeah,
is
it's
changing very,
unsettling.
very
Would be a
quickly.
good word for
And
me.
yeah,
Yeah.
and the faster it changes, the faster it changes, and then the faster it changes, and that's the meaning of exponential. So Umair Hague has written an article just yesterday, actually. He just published it. It's called The Age of Extinction is Here. Some of us don't know it yet. We're crossing the threshold of survivability, and there's no going back. This is a hard hitting article, and I highly recommend it to all of you out there. And I'll give you, Sandy, the link, and you can put it in the show notes. But he talks a lot about India, and he talks about eagles flying and dying in the sky as they're flying and just falling onto the earth dead. And it's a pretty hard hitting article. He says there are the streets in India, I'm not sure where he's talking about, I think up near Pakistan, are lined with dead things. Dogs, cows, cats, animals of all kinds are just dead. They've perished in the killing heat. They cannot survive. And the thing is, when it gets that hot, I think it got up to what, 45 or 50 degrees? It got up to 114 degrees Fahrenheit around the border of Pakistan.
124.
Was it
Well,
124?
my
Okay, thank you.
brother works with some people that are in
Yes,
India, and he said
yes.
they're devastated. They're even in the building they work at. It's they're using headsets or computers. It's not just a call center, but it's happening. It's terrifying to
It
them.
is.
And what you just said to me, hearing about the animals and the critters and all, I can't handle it. And I'm going to have to handle it. I'm a climate change commentator. I mean, I have to handle it.
Yeah. Yeah. Well, those of us in this community, Sandy, Jim, and Nick, we've been talking about this. All of us in this community, we've been talking about this sometimes like nigh on 2 decades, right? And
Yep.
we've been called alarmists. We've
Yep.
been made fun of. We've been insulted for speaking our truth because we could see that things were about to happen. Well, guess what? It actually is happening right now. We are at the threshold of a cataclysm right now. And some people said we're always thinking this isn't going to happen, or maybe it might happen. Actually, it's happening right now.
Yeah.
If I,
Yeah.
oh, go ahead, Nick.
Uh, go ahead. I think you have more of a thought.
Um, there's a couple of things. to what Jennifer just mentioning. One is that this research group called PIK, that at Potsdam, Germany, um, they have established themselves, in my opinion, as probably the world's premier climate change research institution. And they have completed a comprehensive study examining, now granted it's all modeling, but they wanted to explore the interactions among the tipping elements themselves. A lot of studies look at what happens with AMOC or what happens with ENSO or the Arctic sea ice in general, like around Antarctica or the Amazon. They did a synthesis study in which they looked at the all the potential and possible and documented interactions among these various tipping elements. How does ENSO impact what goes on with the Amazon? How does AMOC impact with the sea ice? And how they all impact together, etc., etc. And what they found was what I thought was a very alarming finding. And their result was that an increase of 1.3 degrees C is sufficient to cause climate chaos. Now, the IPCC keeps saying 1.2.
Oh, we froze
Oh,
up.
he'll come back.
Information, a lot of the information. Hello?
I
Yeah,
got
can
you.
you hear us?
I hear
Yeah,
you.
we can hear you. We just had a
Yeah.
little blip on the
Oh,
radar.
okay. It kind
You're
of went
back.
for more. A lot of cases I'm seeing are saying 1.6, 1.65 perhaps. But even so, 1.3, whether you want to say 1.2, what have you, we're there. And we're already
No,
seeing the
we
climate
are.
chaos taking place all over the place. The other thing
Yeah.
is that a lot of biologists are of the opinion, and they state that an increase of around 5C, well, actually more, like, excuse me, 4C, is sufficient that humans go extinct. And
Well,
we're
we're
on an
gonna get
accelerating
there.
path. And some of the estimations are 5 to 11C by the end of this century.
Yeah. It's scary, extinction, the event. You can literally see it happening as we look out. I
Yeah.
mean,
But
we
as
see
we
it
have
happening right now.
we have talked about the fact, and a lot of people do talk about. I mean, yes, there's a war, and we have a question about the nuclear aspect of that, but enclaves of people surviving. But that's all, again, we say it over and over, it's all contingent upon the nuclear power plants being shut down properly because as Antonio was talking about in his Mars show, radiation is no joke. No joke. So there are a plethora of competing issues coming to us at once.
Mm, 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 mm. It's unbelievable. So we're probably heading for 3 degrees right now. Does anyone know when we might hit that 3 degrees above? Because we're about 1.3 at the moment, officially, I think. Are we going to hit 3 degrees by 2040?
Probably.
Yeah, I think I've heard the absolute worst case would be 3 degrees by mid-century, which would be frightening,
I don't think that's
terrifying.
the absolute worst case. I
Well,
really
I mean,
don't. I think that's the
yeah,
absolute best case. It could
worst
be
case as far
more.
as the IPCC puts out.
Oh,
Yeah.
Yeah,
well,
so
Yeah.
yeah, I
Oh,
mean,
oh,
yeah.
And then
I
there are
mean,
those that
as
are
far
going
we're
as
to.
smoking
I
something.
mean, as far as like how it actually ends up going, much of it depends on a lot of these, feedback loops and the interactions between these tipping points that we really don't really understand, just because they're so complex. Um,
Mhm.
but yeah, I mean, the relatively, and it's still fast by any sort of incredible, um, by any standard of natural climate change, is still ridiculously fast. the IPCC's um, um, projections. But if you're talking, the business as usual, blah 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 blah, then yeah, mid-century would be 3C, and I mean that's a completely like altered state. I mean it has nothing, nothing familiar to this climate that we're even in now in 2022. I mean it's completely altered. I mean it's like having the the heat wave that hit the Pacific Northwest, where I'm originally from. I grew up in Seattle, happening, all the
Right.
time. I mean, it's that kind of climate where you're getting 110, 115 in Portland and Seattle. And I mean, it's absurd heat that is threatening to people and animals that aren't accustomed to living in that kind of climate. Um, I mean, the climate change that we've had even since I've been alive. I just turned 38. Is incredible. I mean, the things I've seen growing up, mostly in Seattle, to have seen what I've seen in that amount of time is absolutely unbelievable. And in terms of changes in the climate, from the heat to fires, to drought, so much more drought. Um, it's uh, it's
Since we've
it's
started
it's
the
just incredible.
show.
Yeah.
No. Yeah. So I'm going to read you a paragraph from this article from Umair Haque. This is the threshold. We are already hitting it. We can see it now in startling, grim, vivid detail. The event is not some kind of abstraction or prediction. Extinction is now really happening in plain sight in places around the globe. And they are revealing to us the limits of what our civilization can survive. That limit is hit somewhere between 40 and 50 degrees C at and getting up to the air temperature. After that point, life as we know it comes to an end. That's a really hard thing to get your head around, how fast this is happening. Um,
Well, I think it was James Lovelock who, a couple months back, opined that by
yeah.
2070, 2075, something like that, about there will be, he said approximately, I guess he was being optimistic, 2 billion people left on the planet. Well, if we're about, say, 8 billion, that's what, 25% of current levels. So that's a considerable drop off. It still is above the carrying capacity, to be quite honest, but it still is just like, that's
Mhm.
staggering to think of that. And
It
that's what,
is.
50 years away. That could lose 75% of the
It's
current world's population levels.
it's staggering that, this is so close and that it is so hidden. It's staggering that people are still breeding like flies. I mean, stop breeding now. Don't have any more children. It really isn't a good idea. Says here, our civilization collapses somewhere between 50 and 60 degrees Celsius. Bang, poof, gone. Nothing works after that point. Everything begins to die. Not just animals and us in the case, but our systems which depend on them. Economics crater, inflation skyrockets, people grow poorer, fascism erupts as a consequence. You can already see
That's what we're
that
seeing.
beginning to happen around the globe, and it's just beginning. Just imagine how worse inflation's going to get when extinction really begins to bite. So we can talk about maybe food. I mean, if we're going to get temperatures that hot and our grain is not going to grow, what begins to happen? I mean, we've always kind of assumed there'll be some food somewhere at some price. Maybe that's not the case. If it gets to be so hot in these grain belts around the earth, what is going to happen to the food supply? Do you guys have an opinion about this?
Well, um, people forget that plants, like any other uh, heterotrophic organisms, do have a preferred temperature range. And most of the crops that we grow, that human civilization is based on, do not like it much more above 85 degrees Fahrenheit. About the only crop that we grow that can tolerate warmer and for that matter, drier conditions is corn. I think there might be one other. So we're
Mm.
putting at risk with increasing temperatures. We're putting at risk crops that we depend on. They're just not going to thrive in very warm and very dry conditions. They'll die, plain and simple. And we're already seeing a reduction in crop yields and the nutritional aspect or quantity, measuring calories, of said crops. So we're harvesting less, and it provides less nutrition. That's just right
Yeah,
there. So we're going to keep.
yeah.
I'm sorry. Yeah, I'm
I
just
was
kind
just
of
gonna
babbling here.
add to what you're saying that it's not the like one-off events that that destroy. I mean one-off events can certainly do a huge amount of damage to crops in a wide uh, belt of area. If you're dealing with a drought that lasts like 2 or 3 years or something like that, it's the persistence. It's when the climate is shifted to an extreme state for so far that even below normal temperatures are are at the upper range of what the plants can handle, and then the average temperature is just isn't, and the above average days are terrible. Then that's when you start dealing with areas that just become that were once um, good for crop growth and yield no longer are suitable for that, and that can be a gradual process, or that can be an accelerating process. It depends on the pace of climate change globally. Obviously, if global climate change continues to accelerate, then areas that are sort of on the margins now end up getting worse. And I mean, you see signs of that in the southern plains. You see it signs of that in parts of Africa, where you're starting to see more drought. Central California, more drought years than not, and more heat than not. That is a struggle for the crops that they grow in those particular areas to be able to handle. And as the global average temperature continues to rise, then those areas are going to struggle more and more to support the crops that we're used to getting. And I mean, I think Central California I can't remember what they grow, but I know what they grow is not grown elsewhere in many other places of the United States.
They
And
grow
that's just one.
crops.
Yeah,
And
yeah.
Lake Mead is oh my God. I looked at pictures. I found the pictures of when I was there. And
Mm-hmm.
it was what, 2000, and I don't know, 12 or 13, whatever it was. I was out there and it was lovely. I mean, there was plenty of water then. It wasn't that bad. And now I'm gonna have to make some kind of video using my stuff that I'm finding from where I've been. I could not believe
Mm-hmm.
it. I couldn't believe it. But and here we are. Um, Jen, I wanted to
Mm-hmm.
ask about the hurricane season. I know Nick had wanted to talk about that.
Oh yeah.
And I have something to forecast, and I know not all of us live in hurricane. Well, it affects everyone. Doesn't matter. I
Mm-hmm.
mean, we have the heat. We've talked about the heat. We're talking about the drop dead animals. Let's talk about hurricanes. Why not?
Yes. So yeah, Colorado State University. I have
I'll show
some
it to you.
scientists there. They've been doing this for I can't remember how long. It was started by one scientist, and then he passed away, and it's been continued on where they do seasonal forecasts um, for the Atlantic hurricane season. They update it and they do it based on various climate patterns, including the El Nino Southern Oscillation and other climatic patterns called teleconnections, things that go on in the atmosphere, normal patterns that go on in the atmosphere, to try to project how many storms, hurricanes, and major hurricanes there'll be in the Atlantic basin. And this is their forecast that came out in April, calling for 19 named storms, 9 hurricanes, and 4 major hurricanes, and basically an above normal season for the Atlantic relative to the average that they have in 1991 to 2020. And a lot of this forecast is being driven by La Nina. La Nina is a pattern where you get enhanced trade winds, easterly trade winds, and it causes a lot of upwelling of colder water offshore Central and South America. So you get a pool of cooler than average sea surface temperatures in the eastern and central Pacific. And so that suppresses tropical cyclone activity. That and the increased upper level winds suppress tropical cyclone activity in the eastern and central Pacific. So we're talking offshore Mexico to Hawaii. So you get less tropical cyclones, but it tends to enhance um, the season in the Atlantic with warmer, above normal sea surface temperatures and lower vertical wind shear in the Atlantic. So you get more storms. And uh, we've had multiple uh, years of La Nina in, so you've over the past several years. So you're getting these patterns of above normal that are favorable for above normal seasons in the Atlantic. And I mean, the past several years, we've had some pretty spectacular hurricanes in the Atlantic Basin. I mean, we can go back to 2017 with Harvey, which there was a study showing at the time that it was much more likely to have occurred the extreme heavy rainfall in Texas because of climate change causing much heavier downpours and storms that stall out and sit over the same place for days at a time. So you had Harvey, you had Irma, Maria, Dorian in 2019 that devastated parts of Bahamas. I have a fellow PhD student here at NDSU that was a first responder during Hurricane Dorian. He's born and raised in the Bahamas and saw the damage and devastation firsthand. We've had a lot of incredible storms several years ago. Michael in Category 5, last Category 5 that hit the U.S. and the Florida Panhandle. So I mean, it's been quite a ride for the North Atlantic in terms of storms and impacts and damage. Laura that hit Louisiana. I mean, I could just go on with the list of names. So, um, it doesn't necessarily, in terms of impactfulness, it doesn't matter how many you get in the ocean. It matters which ones hit land, and
Mm.
you can never know for sure. I mean, Hurricane Andrew, for example, happened, I think, during a La Nina year when it was fairly quiet in the basin. I mean, an A-named storm in late August versus sometimes we get them in June and July in these very active seasons. Um, but obviously, if you get more storms, you have more opportunities for them to hit land and cause harm to people and in ecosystems. So, uh, not looking forward to. I mean, as a meteorologist, it's always meteorologically interesting to see these storms develop and form. But um, obviously, you don't want them to hit land and kill people and destroy lots of property and cause all these harmful impacts that in meteorology and emergency management, we concern ourselves with. So, but it does appear there's going to be an above average season in the North Atlantic basin.
Boy, well, Earl's asking, No flush today. Have we
Uh,
picked?
there's
Any
plenty of
number?
opportunities for
Yeah,
flush.
plenty. Okay, okay, guys. Let's spin the flush dial. What would we flush today? Oh my gosh! I'll tell you what. What I would flush is the heat. I would want to flush. I want to flush the heat away. I don't want animals and everything going. We're flushing that away. There you go. Okay. There's the flush of the day, Earl. Are you happy, Earl, out there? He
Well,
comes for the flush.
something that is going on right now in Siberia. There are massive wildfires just tearing across Siberia. Here's the thing that's interesting. Well, interesting, put that in quotes, is that usually the Russian army is sent to fight those battles, the fires.
That's right.
Well, guess where they're at now?
No.
So now those fires are really raging out of control, and the people there are kind of pissed off because their towns, their homes, everything is just burning down. But of course, in terms of climate, all that carbon that's going to be put right into the atmosphere, and it's going to further accelerate everything that we see. So that's another thing to keep an eye on is how long will these fires go, and they've already been devastating enough as it is.
Yeah, the
Jen, have
past
you been?
several years,
Oop,
we've seen some
sorry.
pretty. I was just gonna say, the past several years, it's been fire has been all the rage. I mean, it just seems like fires have been from Cali. I mean, basically California, Canada, um, the the subarctic, basically, or the forests of Canada and particularly Russia on fire. And then, of course, a few years ago, you might all remember the Amazon being on fire with, with the getting so thick, towns went into darkness, and parts of the Amazon, parts of Brazil from all the smoke from the fires there, and of course Australia. My goodness, Australia is just like in the firing line, literally for bushfires. Yeah, I mean it's really a tragedy to watch. Climate change just cause so much dryness and heat, relative to the climate,
Yep.
historic climate conditions of these areas um, that you have all these fires erupting, and it's all carbon being burned, rapidly into the atmosphere, is adding to our woes with climate change.
And as the permafrost thaws, the ground dries out, and now that becomes just a lot of fodder for fires,
Mhm.
becomes more prone to fires, and we're seeing more and more fires in the Arctic region. It's not just Siberia. We've seen some fires in recent years in northern Scandinavia, across Canada, here in Alaska. About was it two summers ago or so, there was a fire that came within 12 miles of where I live. So,
Oh my God.
and obviously, Colorado doesn't really have
It's
permafrost,
happened
but
to you,
Jen's lived through a
Jennifer.
few episodes herself of
Yeah.
fires.
I got one major one came 5 miles to my close to my house, and a thousand
Geez.
houses burned in like 2 hours. It was just like,
Yeah. And
Yeah,
that's the thing about
one
this
of my
stuff. It's
Facebook
so
friends,
unexpected.
lost their daughter lost their house in that fire. They were one of the first
oh,
Oh, really?
houses to be destroyed because I guess where however the fire started. I don't remember how it started, but it was like 1,000 feet, 1,000 feet away that it started, and they had to leave like really quick. They were one of the first people to have to get out because it just spread so rapidly.
And it's worth noting that that happened on New Year's Eve of this
Yeah.
last New Year's. That was just 5 months ago on New Year's Eve when no fires should be going on, and this huge wind just came out of the mountains like 100 miles an hour, tearing through everything, hot wind, and it just became, I don't know how it started either. I don't know that I heard how it
I know
started, but
that
if you
I think
get
they thought it was a power line or something that came down in the wind.
could be. Could
Yeah,
be. Yeah, I mean, the wind was absolutely incredible, and it just became an ember storm. And if you can imagine, because everything's dry like tinder, all these trees, and they, half of them have got like the beetle, so they're like half dead anyway, and it just races through, and it's just like all of a sudden, boom, combustible,
yeah,
It's amazing how quickly these things happen. And it's happening right now, all these birds are flying out of the sky. These animals are dropping dead from heat, you know. Um, our systems are beginning to fail. And this is
Mhm.
extinction. This is what it looks like yet. The early
Yeah.
phases
Yeah.
of it. I don't think we're anywhere near into how bad it's gonna get. Um, Unfortunately.
And just weird things happen even here. I'm going to look what the weather yesterday was like 88 degrees and now it's 57. And it was almost 90 and the greenhouse had to be my greenhouse. I had to have my big ass fan in there. You have to have but I had to put the fan in there. I'm not going to lose the babies. And then I
Mm,
think about all the shit that's happening in other places and I think, oh my gosh, what I have here is nothing in comparison. And I was lucky that I could plug in a big fan. Oh, but it just
yeah,
makes me feel a little overwhelmed today,
yeah,
maybe. Some days I can handle
yeah.
it way
And
better than politics.
I just wanted to make a quick note, and just like a couple weeks before that um, fire in Colorado, you had those monster historic tornadoes in parts of you had a couple of outbreaks in Nebraska, Iowa, and then the one in the south that generated that massive tornado that went through parts of western Tennessee, western Kentucky. I mean, it was ridiculous. A long track tornado over 100-mile track. Yeah, it was
That
quite
was incredible to
incredible.
watch.
mm,
I
Yeah,
watched
mm.
Reed Timmer. Reed, he's the biggest
yeah,
tornado chaser. He
yeah. I've met him.
holy you have?
Yeah,
Really?
yeah, like
He
10 years
just
ago, but yeah, I
holy
met him.
crap, that's what this guy lives for. And when you
Yeah,
watch his channel, I used one of his clips and he wrote to me. He's the one I got the content problem. But he wrote to me. He said, "Listen, I can't do anything about it, getting rid of it, because I have on any one thing, I have like 100 people using my clip." And I said, "Okay, I'm sorry." But he was nice to me because he wrote right to me. So you've met him. So
No,
he's not a jerk, but
no.
he's got insane
no.
footage. And that last one was something I mean I had never
Oh
seen
yeah,
before. There were
yeah,
two of them at one time.
yeah.
A
I think the one
double
was.
double tornado?
Double
Yeah,
header. Yes, it was.
yeah. I
Yes,
know
it
you got
was.
Yeah.
that. Yeah, I know you got that amazing drone footage of the Andover, Kansas tornado of a couple weeks ago. Yeah,
Yeah,
that was
that was it. It must have
ridiculous.
been it. Oh
Yeah,
boy. I have
yeah.
a question. Jim, are there ever any tornadoes in Alaska?
Um, Many years ago, I was driving east of Fairbanks to a place called Chino Hot Springs, and it's a hot spring there. And on the way back, it was like, what the hell is that? And it looked like it was a funnel cloud coming,
There was
getting ready
something.
to touch down. It never did, but it was definitely a funnel cloud forming. So
Mhm.
I can't really answer that from confirmed, uh, you know, data, but I've seen funnel clouds form. I'll
Yeah,
just leave it at that.
there have been tornadoes in Alaska, but they're quite rare
Mhm.
because it don't get warm
Okay,
moist air enough there.
quite rare now. Quite
Yeah,
rare now.
Yeah.
Remember, everything was quite rare. Yeah.
Sandy, there was
Might be more
a
tendency for
graphic.
water
There
spouts.
was there was a graphic I sent you that showed the descent of the, I guess, the jet stream over North America. I'd like to just take a look at that if
Yep.
we can,
Wait a
because it
second.
got pretty crazy here in Colorado the other day. On
I'll get it on.
Thursday, it was just about 90 degrees. And on Friday, it snowed and it was 32 degrees. So, those of you who know where Colorado is, check this thing out. This just happened. Check the temperatures out. And you can see it's just dropping down. And do you see where Colorado is? It's, if you don't know
Yeah.
your geography, it's one, two, three. It's the fourth state from the left, I guess, right? And see that purple thing just
My
like kind of
pointer won't
pulsing
work.
there?
Yeah.
Yeah.
Ooh.
And that is a, and with that came a huge amount of wind as the temperature changed, and then a huge amount of snow. So it snowed about 7 inches here, and it was kind of a blessing, really, because we needed the water. It was very dry, but look how quickly things can happen. And this is just cold air coming out of the north, right? And meanwhile,
I
this
think
is
it.
happening while there's like this huge heat wave in India, a huge heat wave across Europe,
Yeah.
you know?
Wild stuff.
Tis,
It
tis.
almost looks like it's reflecting the more meridional jet stream flows that we are seeing.
Yeah, indeed.
Too bad I didn't set up that. The Ventuski, I didn't set it up. I didn't know I was going to be out here. I would have, and we could have seen the jet streams. Oh, well,
Hmm. Thank you, Sandy.
you're welcome. That was a good graphic. It was
Yeah, that
definitely a
was from
good
Scott
graphic.
Duncan,
Yeah.
our meteorologist. Did you know that Scott Duncan is Scottish?
No, I didn't. He is?
Yeah,
yeah, I follow him
yeah,
too.
Really?
I follow him too. That's where I've been
yeah.
keeping track of what's going on in world weather because I don't get as much time to do that anymore since I'm in a different field.
Yeah.
but
Well, yeah, you're
um,
working hard on your
yeah,
PhD stuff. Absolutely. Is there anything you guys want me to pull up while I'm playing around? I could try.
no, I got nothing.
Okay,
Nope.
well, Jen, I know you wanted to talk a little bit about that. You know, you usually track the methane also. What's going on with anything happening in the methane leakage world?
Well, there must be because there is a huge anomaly of heat across the Arctic. And if you can try to pull this up, Sandy, I'm just going to pop it into the chat. See if you
Okay.
can pull that up.
All
Um,
right. I will.
and what's most notable, let me see, let me go back to your picture so I can see when you are able to get it. What's most notable about this anomalous heat. It's basically at 2 meters, so basically at ground level. Um, the anomalous heat using a base between 1979 and 2000 is their, I
I'm
guess,
getting it.
20-year base. But right at the edge of Russia, where it touches Alaska, that place is anomalously hot. And also in Siberia, directly in Siberia. So, what's so interesting about this picture is how hot, really hot Siberia is. And it's really focusing in that area nearest the Kara Sea, and how anomalously cold North America is. That is so interesting, isn't it?
Yes. It's always interesting. I mean, that's a topic that It
Yeah.
it never gets old. Lisa was asking in the chat what kind of she was saying from fracking, and no. This is different. Maybe you
Mhm.
could just go over it a little bit and explain it, Jen, in only the way
Sorry.
you can. Just explain
What?
the methane issue a little bit.
Oh, the Arctic methane issue?
Yes, yes.
Oh, okay. Yeah, there are lots of methane emissions around the world. South America and the Amazon has been venting methane. They always talk about methane that comes off of livestock. They also talk about the methane that you can cap off, with all those fracked different wells and things like that. That's all true. That's still going on the rice paddy methane, agricultural methane.
Mhm. Mhm.
But there is another source of methane that is becoming more prominent. It's not that prominent yet, but that is the Arctic methane the arc from the methane hydrate, which is a frozen methane, and it's very compressed and it's very condensed and it's very powerful. And as the temperature starts to go up, that methane loses its ice cage and it expands and there's immediate heating. So the point of the matter is there are tremendous methane deposits throughout the Arctic, a lot of them under what is now the Arctic Ocean on that East Siberian Arctic shelf over by Siberia, the Kara Sea, the Laptev Sea, the East Siberian Sea, plus all that permafrost area, which is Siberia, and
Mhm.
permafrost in other areas as well: Alaska, Canada, Sweden, Norway, places like that. You know, any place that there is biological material that has been buried, rotted, condensed, it over the years can turn into a distillation of methane. And that is what we find is happening in the Arctic as the temperature is raising, especially over the East Siberian Sea and that entire shelf area that is by Siberia, from the Kara Sea to the East Siberian Sea, including the Laptev Sea. That whole area has ginormous methane hydrate deposits, and it's going to go into the atmosphere as it thaws out. I mean, there's really no way around that. Some of it will be absorbed into the water column, but the water in that area is incredibly shallow because it's newly submerged, right? When I say newly, I mean in the last 10,000 years.
Right.
Um, so it's not going to stay frozen forever because ice plus heat equals water, and it's getting hotter. So those methane stores are starting to really vent, are starting to really go off. You may have seen these exploding craters in Siberia, in the Kara area, in the Yamal Peninsula. And
Mhm.
that is the Arctic methane that people are worried about. And it has
Yes.
been termed the methane bomb. Well, it doesn't mean it's going to explode, but it does mean that a huge amount of methane can enter the atmosphere fairly suddenly, as it all goes off and goes into the atmosphere,
Mhm.
and it has immediate heating potential. That's the danger there.
Yeah. And Lisa had also said, and she the stuff gonna have viruses and germs too. Oh yeah, we have that added lovely thought.
Hmm.
Well, there's something to add. This shows you the importance of the ocean's warming and the effect that it has in the Arctic Ocean. We have the warming Atlantic waters coming in through Fram, and it's gone through the Barents, working its way through the Kara and the Laptev Sea. But we also have the infusion of water coming in through the Bering Strait from the Pacific side that is warmer, and it's also coming in at higher sea drift amounts, which means that there's more of the water coming in and it's lasting longer. And this warmer water is definitely having an impact on the submerged uh, methane hydrates, that the permafrost on the shelf, the oceanic sources, and that is contributing to that permafrost thawing, releasing the methane. But there's two different sources. We have the biogenic source, which is on the shallow shelf, which we see on the terrestrial side. But the
Mhm.
recent studies done in the LabTEP C at the shelf break, where the shelf transitions to the slope, um, found thermogenic sources of methane, basically pockets of methane gas that are trapped, through various geological formations, and that the warming oceanic waters being introduced there is helping to liberate such deposits, where we start getting explosions, literally, of this gas just boom, and it's just blasting right through the water column. Not much is being absorbed by the
Wow.
water column, and just blowing right up into the into the atmosphere. It's kind of interesting because way back in last century, Igor and I actually submitted a proposal to study the methane deposits, the effect of oceanic water on the methane deposits on the shelf. It didn't get funded, but there was like, well, that's Russia, the U.S., and there's all sorts of political stuff going on. It didn't get funded, but I'm glad to see Igor has persisted and he's doing the work there, and he, along with Natalia, of course, and they did do. The study the terrestrial side, but Igor has he has documented a lot of these exploding, you know, methane burps, shall we say, of
Right.
just this huge methane just coming to the surface. We're talking, bubbles like about 3-4 meters in diameter, and that's like one here, and it's like all over the place. Just these huge
Right.
amounts of methane just coming up through the water column, going right into the atmosphere. It's just incredible.
So, Jim, if you were a ship and you were going along in the Arctic Ocean near those methane deposits and one of those big bubbles comes up under you as you're going along, what do you think's going to happen to that ship? Do you think that the buoyancy is going to be a lot less and it'll sink into the water, sink into the bubbles?
I mean, the bubble will disperse, and I mean, if it hits the ship, I'm not sure I understand
No.
what you're getting at there. It's
Haven't you
not going to
heard of
sink the
this?
ship.
No, it has happened before. Don't laugh.
It,
Oh.
well, I've been on a few cruises there, and I know. Um, it depends on the size of it. I mean, looking at what Igor is finding, or
Mhm.
at least documenting, is nothing that's large enough to impact a research vessel. I mean, it depends on what the size of this,
Okay.
explosion is. Depends on the size of the vessel. It depends on other circumstances. I've never experienced that, and I've done my
Well, of
share
course,
of.
you wouldn't have experienced it or you wouldn't be here.
Yeah, we're
But I
glad
have
that you're
heard
here.
this before. I have heard that, when it's so much bubble and like carbonation almost in the water column, the ship goes over it, there's not going to be, it's going to decrease the buoyancy. I've heard that.
Mm,
Wow.
I've not
Something to
heard
look
it.
into.
I've not heard it from colleagues. Let's put it that way.
Well,
All
look
right.
into it because that might be good, good information for us to do a show on if it's out there. If it's out there, we'll find it.
If it's out there, we'll find it.
Yeah.
Which
I
brings
think we
us
need to go to
to we've
questions.
oh, okay. Yeah.
Everybody's
Just
asking
let
for
you, just let
questions.
you know, I have to leave in like 5 minutes
All
because I
right,
have
then let me
meetings.
let me get to the questions now. There are people that are asking me questions that the chat's going very fast. If I don't get to it, I am terribly sorry. Let's get to what might nickel that goes to Nicholas. So all right. All right, let's see. Nicholas. This might be you. How high will wind speeds get in the next 5 years?
Probably no dramatic changes. It just depends on if you're talking about hurricanes. It probably won't be any dramatic changes over the coming years. If you're just talking about the prevailing winds, um, probably nothing dramatically changing in the coming year, in the coming 5 years or so.
Okay. Have another one. Nick from Poppy. I expected tornadoes to increase in Missouri, Kansas, Oklahoma, Arkansas corner area, but they've gone elsewhere this year. Que pasa? What the
Well,
hell?
I know that I need to look that up because I know they've been trying to pin down connections between La Nina and tornadoes. I think they might be speculation that there may be periods of more tornadic activity during La Nina years versus El Nino years, but I haven't looked at the recent research into that.
Okay. All right. Now let me see if there's anything else for you because I know you have to go. Um, Nick, maybe this one's for you. Is it drought or desertification we should be talking about? We are no longer in a stable climate, so talking of longer and longer drought seems like denial or disavowal. Who wants to take that one?
Well, I mean, I could add that, yeah, I mean, climate scientists in particular are really interested in talking about desertification. I mean, it's because it's basically droughts are getting longer and more intense, but it gets to a point to where the climate is actually changing so much that certain plants aren't growing in certain areas anymore. The animals move on to other areas because the plants that they depend on aren't growing in those areas anymore if they're herbivores, and then you get these changes in ecosystems or collapse of ecosystems because of a switch over to desertification. I mean, you can see that happening in California. You can see it happening in Southwest U.S. Places that even are dry are just getting drier. They're getting drier, longer, more intense periods of no rain and it's causing harm to people. Water wars even between between states that are trying to get water from, say, the Colorado River and other areas. And of course, animals and plants are suffering as well because of that long-term desertification.
All right. Here's one that Nick, maybe you want to answer, and then any of us could answer from Heidi. No doubt about stopping having children. We have an overpopulation explosion and massive dwindling resources. It needs to stop. It probably won't with Roe on the table. Anybody want to take this one? Nick, you want to take this one? It's a little political, but it does, kind of.
I don't really have any.
It's a hard one, Heidi. It's a hard one, Heidi, because that brings us into kind of a terrain that we don't have enough time with. But I put it up there.
Yeah, I think we could make a whole show about that.
Yeah,
Obviously,
we
we're
could.
all going to have very strong feelings about Roe
Yes.
going away and women's
Yes.
rights going away. But that's like we're 20 minutes past the hour, so
Well, let's
you know.
see. I figured we'd go till we could get a few more questions. What do you think, Jed? Couple more? I got one. Okay. Wondered if the activity of volcanoes lately has anything to do with climate change.
Uh,
Well, I mean, volcanoes can get more active if there are pressures being affected on the continental plates due to ice being displaced, isostatic rebound being in play. Things can shift around. When faults and continental plates ease and shift, there can be more volcanoes, but I don't have statistics on that. Now, volcanoes are supposed to cool slightly because of all
Yeah.
the global dimming, particulation they throw out, but that's a temporary effect. But I have heard that there can be more volcanoes
Okay.
in this time.
And Rich Diana has one for you, Jen. Sam Carana says we're already over 2C. And aren't you, Sam Carana?
No. I am
Everybody's
not.
got
I am
it. I
not.
think I thought
I
that was
am
a good one,
definitely
Jen.
not.
Everybody
I
thinks
I am
everybody.
just I am just a Johnny come lately or Jeanette come lately. I mean, I definitely am not. I reached out to Sam Crana 8 years ago when I was doing the methane monster and became acquainted with them, whoever they are, um, mysterious
I know.
scientists.
Everybody has
Yeah.
an idea of Sam all the time. Every time we do the Sam show, it's is it that Maria, whatever her name is, or is it you, Jen, or is it, that's always
Oh
fun.
well, I will tell you, I have absolutely nothing to do with Sam Carana, and I am not him in
Here,
any regard.
here's
But
Trulia.
I'm
We'll just,
honored. I'm honored that you would even think that. But
yeah.
no, I
Yeah.
am
Well,
not.
listen. So, well, Jen, I'm going to give it to you.
Well, this is such a time of change and things are really speeding up. This article that I will send you the URL for that, Sandy, and you can put it in the show notes of Umair Hague, put it very, very well. It's happening now, and it's just that not everybody knows it yet. But whether they know it or not, the age of extinction is here. It's rolling out before our eyes, and everybody who's watching this show is a participant in understanding this. So, although some of us don't know it yet, it's definitely not the ones in this room. We understand what's going on. So, I guess, let's just keep studying this together, but things are speeding up for
Things are
sure.
speeding up.
Things are
Well,
really
even though
speeding up.
Antonio couldn't come, and I was sorry about that, it's been wonderful to be with my team. It's been wonderful to be with you guys. And I
It's
want to
been
thank you
wonderful to
all.
be with you too.
Yes. And thank everybody out there. We have almost 100 people. We had over 100 people. It's too many to say the
And
names,
my
but
cup.
yeah, oh, yeah, Jennifer got her cup. Don't forget,
I got
if
my
you want a
cup.
cup, you can make a nice donation, and it's $10 shipping, unfortunately, in the United States. If
Yes.
you want a
Wow.
cup, make a nice donation on Buy Me a Coffee. It's the show notes. Jim, have you anything to say before we go? Don't forget Jim's channel.
Um, I still go back to about 1994, 95, 96, that time period when the ocean's ability to sequester heat and carbon to depth changed. The oceans are no longer
Boom.
able to sequester heat and carbon to depth. Therefore, this heat and carbon is accumulating in shallow layers. And in my analysis of looking at all of the physics behind that and the heat content and so on, I have identified that as the tipping point for the planet. And so basically, going back to the mid 90s is when kind of the fate of humanity got locked into place. And we're now a little bit of a lag effect,
Yeah.
but we're now starting to see everything come home to roost. Hate to say.
And there you have it. WASF. Thank you, Nick. I am saying toodaloo. Jennifer will be with me on Wednesday for our Arctic show. Look forward to that. Buy us a coffee. And hey, love you guys. Love you all. Thank you all for coming.